Okay, so the previous example with IQs is an example of what's called one-sided tests. And it's also possible to conduct what's called a two-sided test. So let's do an example here. So let's weigh a 1,000-gram test weight 60 times. And so let's collect 60 measurements. And suppose the sample mean is 1,000.6 grams and sample standard deviation is equal to 2 grams. So 1,000.6 is not exactly 1,000. So the two hypotheses, null hypothesis and the alternate hypothesis, can be formed. So what we want to believe is that this scale we use to weigh the weight is off, which means the population mean is not equal to 1,000. So this means our scale is off. And the opposite is the null hypothesis, which is the one we want to reject. It says that the population mean is equal to 1,000. Translating words means our scale is fine. So same thing, we were going to first create a null distribution. We have a large sample size, so we can use the central limit theorem. So the null distribution is the normal distribution with mean being 1,000 and variance being the sample variance divided by the sample size, which is 60. So the standard deviation is equal to 0.258. So the null distribution looks like this. The mean is 1,000. And our sample mean is 1,000.6. So let's draw that. 1,000.6 is here. So let's first calculate the z-value. So the z-value corresponding to 1,000.6 is equal to 1,000.6 minus 1,000 divided by 0.258, which is equal to 2.32. So the difference between the one-sided test and two-sided test is that the p-value not only calculates the area of this tail, also calculates the area of the corresponding tail on the other side. So corresponding to z equal to 2.32 is z equal to negative 2.32. So we also take account of the area of this tail. Now if we look up the z table, we know the area of this tail is equal to 0.0102 because it's symmetric, so the area of this tail is also equal to 0.0102. So the p-value, which is the area of the two tails, is equal to 0.0204. So because the p-value is equal to 0.0204, the conclusion we can draw is we are 0.9796 this much confident that H0 is false, which means we are really confident that the scale is off. Okay, so in general, there are three kinds of hypothesis tests. So null hypothesis, alternate hypothesis, and the p-value. So there's the one we just had. The null hypothesis is the population mean is less than or equal to a certain value, and the alternate one is the opposite, mu 0. And the p-value is the area of the right tail. And we can have the opposite, so the null hypothesis being mu greater than or equal to mu naught, and the alternate hypothesis being mu less than mu naught. In that case, the p-value is the left tail, the area of the left tail. So these two are one-sided tests. And we can also do a two-sided test, we just did. In that case, the null hypothesis is mu equals to mu 0. And then the alternate hypothesis is mu not equal to mu 0. Then in that case, the p-value is the area of the two tails. So this is a two-sided test. So here are some observations to be made. First, because the two-sided test counts the area of two tails instead of one tail, so the p-value of a two-sided test is twice of the p-value of a corresponding one-sided test. And the second thing to notice is, so this is a warning. So in our book, the null hypothesis is the opposite statement of the alternate hypothesis, but in most books, the null hypothesis is always the same. It's mu equal to mu equal to mu naught. So in that case, because the null hypothesis is always the same, to tell which kind of test it is, we have to look at the alternate hypothesis. Yep. And books here includes GeoGebra, which also performs hypothesis tests. All right, so that's it for section 6.1.